Hello, welcome back to this series of videos. Today actually we'll start a new series which is titled Covenants, just that. So in this series I will explore the covenants topic in order to be able to produce an article that explains which solution do exist under this category and how are they different between each other. For the first minutes of this video, my voice will be recorded at a lower input because I'm not sure if you can hear. There's a lot of noise close to my apartment. Therefore, yeah, we have this inconvenience for some minutes now. But let's go into directly to the point of this video. Let's switch and let's start like this. So when I have to learn something new, especially about Bitcoin, and I don't know where to start, I just go to Bitcoin Optech. Bitcoin Optech is a source which I already introduced in my last videos. Is a group which works to bring the best open source technology and techniques to Bitcoin using business in order to lower cost and improve customer experience. I mean, it's kind of an articulated statement, this one. For me, this is, I would say, a magazine, but also an encyclopedia, because, for example, in this case, I will start my exploration of this topic by going to this section here, the topics section, and I will go to C for covenants, and as an encyclopedia you have this list of topics where you can find the one you need. So let's go. This is the covenants topic. As you can see, there's a brief presentation of the topic, and normally you have links to documentation and code. And another big part of this website is the number of newsletters and articles they share in their newsletter. Yeah, so if you subscribe to them, you will receive all of these information just about covenants. But yeah, you can imagine, like, every week you have a newsletter full of resumes about many topics and many discussions. Therefore, yeah, I think it's a really useful instrument. Okay, what are covenants? These are a category of proposed changes to Bitcoin consensus rules that would allow a script to prevent an authorized spender from spending to certain other scripts. So it's a way to put rules on the next transaction in which a certain UTXO will be used. So you limit the type of script in which it can be included and used. Okay, therefore, for example, a covenant may normally only allow spending to a whitelisted set of scripts, such as returning bitcoins to the user's own balance or spending to a staging address that only allows spending to an arbitrary address after a period of time. Okay, therefore you can imagine these are only two examples of how you can limit the spending of a UTXO with covenants. Primary code and documentation. So enhancing Bitcoin transactions with covenants. Okay, there's this white paper. This paper written by someone financed by Blockstream. I'm not sure if they are directly employed in Blockstream or if they are just financed for this work. We can we can search about this later. Okay, so the title is Enhancing Bitcoin Transactions with Covenants. And when has it been written? Do we have any idea? Maybe we can derive when it has been written by the set of by the reading bibliography. So they are citing 2015 resource, 2014, 15, 2000, 16, 15, 16, 15, 16, 10, 10, 16. Okay, so I suspect that what I read here in the title of this document, which is Bitcoin 17 Final 28, well, it might mean that this paper is from 2017, which is nice, of course, but as we discussed in our previous video, covenants have been at the center of a growing discussion since those years in which this paper has been written, and then some new elements have been added to the discussions. I will keep this document in the list of those resources which are important to understand the history, but maybe from the technical point of view we can find something fresher. I'm not sure. In the end, this document has 8 or 9 years, so let's see if we can find something else. Okay, so as we can see, also Bitcoin Optech has the first resources coming up in 2018. So okay, to have an idea about the topic, the history of the topic we're treating, the discussions about this technology starts in 2017, maybe a bit before. Maybe they mention something here also about history and timelines. Okay, so Scaling Bitcoin Tokyo 2018 script roundtable. Okay, so 17, 18. Nice. So one thing that we have to understand with covenants is that in many cases these techniques are thought, first of all, in order to squeeze this language which we use to define transactions in Bitcoin, which is script. So script is a really limited language, and covenants are a way to expand the possibilities we have when building transactions with scripts. What does mean to expand the possibilities? Script is a language which is not Turing complete. This means that many type of statement can be represented. Therefore, with covenants, what we do is to expand the type of operations we can perform with a script. Okay, so we have a document from 17, 18. Let's see if we find something like I see here in review 2019. The last time I reviewed these 3 links, which represent three of the main forms of covenant which are being discussed nowadays. For example, I was mentioning that covenants are thought to expand the possibilities we have when using script. And here in 2020, there's this discussion about simplicity, which will be a complete alternative to script. So it's interesting to see what they are talking about here. Here we have some prototypes. So in reality, I will go through all these articles, but let's open a bit of them so we have an idea of how the discussion evolved. At what point is the discussion now? What has been forgotten? Like maybe there's something which has been left out of the discussion after a while. Okay, so replicating the OPCSFS covenant enabling opcode with opcat. So opcat is another technique we have, which is a concatenation technique, which is really powerful and wide, has a wide range of effects when applied. Like opcat is a type of solution. If we have to categorize covenants by the wideness of the impact they can have, opcat is in the biggest one, in the biggest category, where techniques have a huge impact, adding a lot of new possibilities, but of course also a lot of new threats to the system. So proposal for composable OPTX opcode useful for constructing covenants. So in 2022 we have this OPTX, which I've never seen. Recursive covenants, generalized smart contracts. So in 2023 we already have this type of discussions, which include also the effects on the ARC protocol, which we discussed also in the last video. And ARC protocol, which is a technique for sharing UTXOs, virtual UTXOs, so you can build virtual lightning channels. So the ARC protocol basically is a way to avoid some of the liquidity issues which nowadays we have in Lightning. So here we have a discussion about proposed joint pool construction for ARC will be less interactive with covenants. Okay. Using covenants like OPCTV and APO to improve LN scalability. Okay. So here we have the effects on ARC, we have the effects on Lightning scalability. HTLC aggregation with covenants. I'm not sure about the meaning of this. Research into minimal opcodes for output script introspection to enable covenants. Wow. The titles are getting way more complicated by the year. Okay, so the big topic when talking about covenants is how to deploy the solutions uh, without changing the consensus or minimizing the impact on the consensus mechanism. This is interesting. Hmm. So we have also decentralized mining pools which can benefit from these new technologies. Okay, so from here we have a lot of material which will let's select all the tabs here. Let's see if we can do this in some. So bookmark all tabs. We create a new folder. Under Bitcoin Core. Should it be Bitcoin Core? I will say so. I will include it under Bitcoin Core because in the end these discussions are implementation centered on Bitcoin Core. I'm not aware about this type of discussion in nodes or other implementations. Maybe it's better just to keep it for future covenants as an independent topic. Okay, therefore we have all these things here. Let's see if covenants can be okay. One of my first folders. Okay. Nice, so they already ordered in a good way. Shall we start from the beginning? So from the first article available here, which is this paper written by Russell O'Connor Blockstream. So let's see the face of this guy. Okay, Russell O'Connor, which is a person from Blockstream. So he talks a lot about simplicity. Okay. And then we have Marta Piekarska. I'm sorry if I'm reading in a funny way the name, but okay. I don't know if she has a lot of homonyms, but I will put Blockstream. It looks like it's this girl here, this lady. Yeah, whatever. Hyperledger Foundation is an umbrella project of open source blockchain and related tools that the Linux Foundation started in 2015. So both these authors are curious people. Like I would like to understand what they write here. So covenants are Bitcoin script programs that restrict how funds are allowed to be spent. Nice. I love this statement. Maybe it's like really compressed, but yeah, it's clear. In previous work, Moser et al. implemented covenants with a new script operation that allows one to programmatically query the transaction. In this paper, we show that covenants can be implemented with a new check sig from stack operation that verifies a signature for a message passed as an argument. When the same public key and signature is used together with checksig, one can recover transaction data, which then allows one to enforce a covenant. To illustrate our technique, we implement Moser et al. Vault construction for securing funds against key compromise. We use Elements Alpha sidechain whose script language has the needed operations. Elements Alpha. Is a general purpose blockchain platform that can also be pegged to an existing blockchain in order to enable the two-way transfer of assets from one chain to the other. Implementing elements as a sidechain allows you to work around some of the inherent properties of the main chain while retaining a good degree of security provided by assets secured in the main chain. Main chain has no awareness of the sidechain. An open source sidechain capable of blockchain platforms. Yeah. I'm not sure if this is the right document from which I would start. I would like more general approach without specific tools, without specific opcodes. I would like to see if we have, let's see. Let's go on Google and let's start to search covenants. BTC. It's interesting to see that also Ledger is educating people. Bitbox, what are Bitcoin covenants? Are spending conditions that introduce new options for Bitcoin transaction management, allowing more secure and specific control. They sustain that it's more secure. Simple continue. Two proposals, CTV and check the transaction hash verify. Who wrote this? Joko. Who the fuck is Joko? Fell down the Bitcoin rabbit hole. bad username. Website, Twitter, Yoko Ono. Okay, okay. Yeah. Wow, didn't know you can pay. Didn't know you can pay with Bitcoin to McDonald's. This was in 2021. McDonald Bitcoin payments. Huh. So they stopped. Okay. Yeah, I don't know. I don't like this to start. So this collaborative page attempts to be a comprehensive overview of different Bitcoin Covenant use cases and consensus change proposal. Use the sidebar to explore the different use cases and proposal, or check out the summary table. Oh, nice. Nice website. This is Bitcoin Covenants wiki. It's called Covenants Info. I mean, the URL is covenants.info. And okay, what are covenants? The term covenant is borrowed from legal speak and is not very well known in common language. When we talk about covenants in Bitcoin terms, what we actually mean is the ability for Bitcoin script to introspect the transaction it is executed in. So another more descriptive term to use instead of covenants will be transaction introspection or introspection opcodes, specifically when we're talking about script opcodes. Bitcoin script, the scripting language that we use to express conditions for spending and spend transaction outputs, has a set of opcodes that enables users to restrict spending of output based mostly on signatures and timing constraint, so-called timing locks. In principle, script already has certain introspective capabilities, like opcheck_sig, which checks a signature over a sig hash of a transaction, which hashes together a bunch of properties of the transaction. It only checks the signature though and doesn't allow for actually looking into the fields that make up the sig hash. Then we have opcheck_locktime_verify, which checks that the end lock time field of the transaction is higher than a certain value. Then we have opcheck_sequence_verify, which equivalently checks that the end sequence field of an input is higher than a certain value. However, even though the above three codes exist today and in principle provide some very rudimentary introspection in the spending transaction, their capabilities is extremely restricted and intended for some very specific usage. So, when we speak about covenants or transaction introspection, what we mean is the generalized capability of script to look into or assert various properties of the spending transaction. This page is definitely not a finished work. Since it's collaborative, everyone is much invited to contribute to it on GitHub. Nice, interesting. So let me add these to Covenants. Also Covenants wiki. Wow. Sorry? Okay. Therefore now we have the content here. Use cases, proposals, overview, extra. Okay. So just for curiosity, powered by Zola and Daddy Docs. What is this? Static site engine. Nice, okay. Therefore, I really like the way they frame everything here. I think this is exactly what I was looking for. So this was the introduction. Then we have a summary table. Use cases. Therefore, here we have some how to call this? These are some techniques, right? I think so, yeah. These are some techniques of Covenant, and here we have some use cases. For example, the already named ARC protocol, which in this line has its synergies with APO, CTV, transaction hash, TLUV, intro, volt, mat. I'm not sure what they mean. So let's search here the glossary. Yes, if combined with something that allows turning a script into a taproot plus off and also opcat. Okay, CSFS, yes, if combined with checksig from stack. And CTV, yes, but only because the op vault proposal also includes op CTV. So here we have some notation like this, which is explained down here. Okay. Development status for all the techniques. So here we have the status of the discussion for each of the techniques. For example, this one is just an idea stage. And this one has already a Bitcoin Core implementation ready, but has only a draft BIP. Instead, others like these three, which we discussed, especially these two, they already have a BIP and active on Inquisition. Inquisition is a GitHub repository, which I'm not sure how it's really used. I have to investigate about that. The Bitcoin Wiki has a page where certain prominent Bitcoin developers have indicated their support for various proposals, some of them adding a rationale behind their support. Okay. Very interesting. Wow. Wow. Okay, so this is important to be saved here. This list is incomplete and under construction. You are strongly encouraged to include a rationale with your evaluation to ensure that your input has maximum impact. Evaluations without accompanying reasoning may be disregarded. Not sure and still evaluating the data. This is the evaluating status. No, doesn't support. Deficient. Okay with the idea, but considers it to have insufficient community support. Weak, better than nothing at all. Wanting, positively likes the idea, but considers it to have insufficient community support. Acceptable, it is a workable solution. Prefer, the most preferred solution can be used for multiple opcodes to share preference of a combination of opcodes. Okay. What the fuck is Enhance? A soft fork proposal for Bitcoin. OpsCTV, OpsCSF, OpPC, OpIK, Enhance. So people is advocating like building websites, creating explanations. What the fuck? Okay, therefore C4 and C3PO. Oh wow. Oh, fuck you. Okay, I'm not sure what does this mean. Okay, but these four are exactly what Enhance is supporting. CTV, CSFS, PC, and IK. CTV, CSFS, PC, and IK. So imagine that C4 is supporting these four and C3PO is supporting this. Okay. So Cake Wallet is a developer with economic nodes. Okay, so here we have this distinction Cake Wallet. What the fuck? Maybe they put this information here as an entity. Rationale. Okay. Okay, so this doesn't look the first thing I should read. Let's see. Okay. So it's interesting to see, for example, you know, it's interesting that I don't really know the names of these people. Yeah, for example, I know this guy here. I mean, I've seen his username. You know. interesting. Wow. Man, this guy has really good memes. Okay, then let's see who else put their opinion in this page, because the participation to this looks that, yeah, it's this is not a popular list among other type of developers. John Attack contributed, put here his idea, and he's open about OPCTV, and for the rest is evaluating. He's really a prudent guy. Luke Dash Jr. Acceptable, wanting, evaluating. Internal key, no. Deficient, upcut, evaluating, acceptable. It's interesting because I've seen he has, a reputation about being conservative, which I kind of appreciate, because I don't know. I'm normally open. I'm an easy person to convince when talking about adding something new to a project, and I need people like him, to express conservative ideas, which I can use to balance my point of view. Okay. Yeah, I don't see many contributors, which I expected to be in such a list. So I'm curious why they're not here. Okay, therefore we have this summary table, we have the proposals here, use cases, and extra, additional reading, upcut, the great, script restoration. Oh look, for example, upcut has been added to the extra. So let's start from opcat. Introduction. Opcat is a simple opcode that concatenates 2-byte strings together in Bitcoin script. Andrew Poelstra once wrote a 2-part series of blog posts to showcase how the opcat opcode can itself efficiently enable covenants. It's important to clarify that this proposal doesn't aim to introduce covenants to Bitcoin. Instead, it focuses on introducing an opcode that holds broad utility across various scenarios. The potency of several covenants proposals increases substantially when they can be integrated with the functionality provided by CAT. As a side note, opcat is also one of the opcodes that will be re-enabled as part of the Great Script Restoration project. Oh fuck, what's this? The Great automate script restoration. Specification. A BAP of the opcat opcode is currently in draft status on GitHub. An implementation of Bitcoin Inquisition is also available. Bitcoin Inquisition, let's check what these things mean. So Bitcoin Inquisition. Let's see if in Optech we have topics I for Inquisition. No. How do they present here themselves? This organization, blah blah blah. Bitcoin Inquisition numbers and names authority. This repo assigns unique identifiers to propose change to Bitcoin. Identifiers take the form of blah blah blah. A particular revision of a proposal may be identified by appending RRR. Okay. What the fuck is Bitcoin Inquisition, man? I've seen it many times, and it looks like a way to have like an index of the BAPs. See our implementation PR in Bitcoin Inquisition. Okay, so this guy here wrote this draft VIP. Okay, he also has, what's this? Okay, so here we're going in codes, details, which I will explore later. Okay. So we still need a BAP for opcat, right? This is what I'm understanding, that we only have drafts for BAPs. are some of the use cases and script that will be possible with the additional codes. Interesting. It looks like a gigantic work which Rusty Russell is doing. I'm not sure if I understood the meaning of all that conversation they were having there. But yeah, okay, so the Great Script Restoration is undertaken by Rusty Russell. Quiet corner of the internet. I love the title of this website. Restoring Bitcoin's full script power. In my previous post, I've been carefully considering what Bitcoin scripts improvement we might want if we had introspection. Script was hobbled back in blah 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 due to denial of service issues. This has been long ongoing source of regret, but functions like OPTX hash bring script limitations into clear focus. Okay. You all the Bitcoin script. Yeah, all the. Okay, I don't know what this means. Most people know that Satoshi disabled opcat and few other opcodes in this version here, but Anthony Towns pointed out that until version 3 Bitcoin also allowed arbitrary sized numbers using the OpenSSL bignum type. This was early in the project, and I completely understand the desire to avoid those immediately and clearly and restore functionality later once the issue were carefully considered. Unfortunately, the difficult nature of script enhancements was not deeply appreciated until years later, so here we are. Avarop's budget, full script restoration without denial of service. So 342 replace the global signature limit with a SIGOP budget. This is related to Taproot and multisig, musig. So this was designed to be ample for any reasonable signature validation, such as might be produced by Miniscript, yet limited enough to avoid denial of service. Minor changes to semantics, implementation details. Okay. Hey, covenants in Bitcoin, a useful review taxonomy. Covenants are a construction to allow introspection. A transaction output can place condition on the transaction which spans it. This power extends script in useful ways, such as allow creation of forced pending paths and rebindable inputs. But when we discuss specific proposals, it's been difficult to nail down the exact trade-off made by each one, so I want to describe the landscape or taxonomy which we can use to categorize and assess covenants. Okay, this goes here. Firstly, consider the simplest covenant, TXID verify. This will check the TXID of the spending transaction is equal to the given TXID. This is easy to implement both in existing script, replacing op number operational code 3 and in TypeScript. It doesn't actually work since it makes a commitment circle, but it's a useful thought experiment. So this guy proved something. Okay. Fully complete covenants. Now consider the most complete covenant proposal, OPTX. The idea is to push some specified field of the spending transaction onto the stack. For efficiency, it will take a bitmap to push multiple fields at once, and because we don't have opcat, have an option to concatenate them all as push them as one element. There are details here which matter, such as how primitive Bitcoin script is when dealing with numbers and stack space limits for large transactions. But the idea is simple. This allows you to do things like output amount must be measured than .sats. Equality covenants. On the spectrum from simplest to most complete, is Rasus Connor OPTX hash, which takes a bitmap from the stack and hashes those fields together, then pushes the results hash into the stack. Of course, you can have multiple op if branches allowing different equalities, but only a handful. You run out of script space quite fast. With opcat, you could extend this further to assemble a template to compare against at runtime, but we don't have that, so I'll ignore that for now. This allows for simple equality tests, such as output amount must be this number of sats. Op-check template verifies a further restriction on basic equality covenants. It's like OPTX hash with a fixed bitmap. It's an opinionated subset though, which makes it more powerful than OPTXID verify. In particular, it doesn't commit to inputs at all, but commits to all the outputs. This means that you can theoretically add fees and still match, but you can't have a change output. It's also usable outside TypeScript since it's written in the all don't touch the stack script soft fork style. So I'm reading this article even if I'm not really comprehending everything, each word, but I'm getting an idea of how to study this topic. So what I'm understanding is that I need to study script, I need to study operational codes, and yeah, because otherwise I will not understand this work, which is, in my opinion, exactly where I need to start, like a taxonomy, or at least an effort to create a taxonomy of these solutions, how they relate to each other, because in the end it's everything connected. So Taproot allows us to design then restrict. Designing in the second half of 2023, I think it's reasonable to assume covenants are only relevant inside Taproot. This means we have the ability to easily limit it in a way which can be unlimited in stages later via future soft forks. If we only allow certain bits to be set and otherwise treat it as op success, we can trim its ability today and soft fork it in new bits later without needing a new opcode. Okay, so here we're talking also about how to use some existing changes, how they combine each other, and how the deployment will have a different result in terms of fork. As an example, let's turn optx into optx verify. optx id verify. We only define one bit. That bit means push the tx id on the stack, and if anything else is set, optx is interpreted as op success. Okay, so this is an example of a script statement. Similarly, if we want to op check template verify, we require the following optx bits to be defined. There are some differences in how fields are hashed and perhaps their order, but these are cosmetic, not functional differences. Extending this in future simply means defining other fields and what combinations are allowed. The recursion distraction. There are many ways we can argue about how to clip covenants wings, but I want to address and dismiss one specifically, the idea of restricting recursive covenants which restrict all future descendants. Any covenant system listed here can restrict outputs. That means I can require that the spending transaction spend to a spending transaction that spends to a spending transaction that spend to 100 million transactions later and output to me. You could prevent this by requiring that any covenant spending ticks itself is not allowed to use a covenants at all. But that adds complexity and reduces usefulness. Mathematically, there's a difference between being able to restrict transaction to arbitrary depth and to infinite depth. Nobody else cares. Either way, there are far better ways to render your coins useless than placing them in a giant chain or loop. This paragraph is kind of tricky. I want to understand. Stay logged out. I want to better understand this paragraph. Okay, so recursive covenant, there are covenants that apply not just to the next transaction but also to the transactions beyond that, potentially forever. This creates a chain of restrictions stretching into the future. So I understood this. I'm not understanding if the author is saying that it doesn't matter. So it's not useful to any concern about this topic is not really useful. In many ways, about how to clip covenants wings. The author believes that fears about recursive covenants are overblown. While it's technically possible to abuse them to make coins unusable, there are simpler ways to do that, and banning recursion will introduce unnecessary limitation and complexity. Okay. Covenants by the backdoor. I wrote a previous post on covenants via signature, which noted that signature with oh, Jesus, I'm tired. Can be used to make covenants. This is not a neat design, it's more like we have a jackhammer, we can use it to knock it in a nail. On the covenant spectrum, it's an equality covenant between tix hash and opcheck template verify. In that it can be used with several different field bitmaps according to the sig hash flags used in the signature. Introspection is not all we want. It's worth noting that Bitcoin object SIG do three things. Assemble parts of the current transaction, hash it, check the hash is signed with a given key. Is the hash is signed? Okay. OPTX implements the first, and we already have various OPSHA 256 and similar operation for the second. OPTX hash and OP check template verify combine the first two. It's logical to want a separate operation for the third one, hence the proposal to be able to check a signature signs a given hash, check sig from stack. This will let you simulate an object sig variation depending on what we're enabled. We should enable any preval. This will enable LN symmetry, which makes lighting simpler, which has already been implemented. It will also enable covenants, though with a weird requirement for a signature in output, which makes them less efficient than they could be, but enables real uses and experimentation to inform future soft forks. For future covenant soft forks, we should look at complete design like OPTX, then clip the wings as the style so we can enable the full functionality later. This may well end up looking like object template verify. Meanwhile, Greg Sanders, who both defined the opfold proposal and implemented LN symmetry, expressed the opinion that we are fast approaching the edge of Bitcoin script usability, and he now was firmly on the opinion that a soft fork to introduce simplicity would be better. Perhaps that will happen instead of OPTX or the like. Wow. Okay, this is a really good article. So my mission for today, we can say that I accomplished my goal. So I found out an article which, if I read many times, I will every time discover some nuances which will lead me to interesting concepts which I need to study in order to be able to comprehend and discuss the covenants in Bitcoin. Nice. Really happy. I already saved it. So in reality, it's a really nice blog, this one. I will save the entire blog, as the articles are all touching the topic. Okay, and this was another really good discover. So I already understood that opcat is a simple opcode that concatenates 2 byte strings together in Bitcoin script. And it's important to clarify that this proposal doesn't aim to introduce covenants to Bitcoin, but it has basically the potency of several covenant proposals increases substantially when they can be integrated with the functionality provided by opcat. Let's see what's this. So here, who's this? Andrew Polestra once wrote, okay, so this is the blog by Andrew Polestra. So this is the first in a series of posts about covenants in Bitcoin using Taproot and hypothetical cat opcode. Historically, and as has been implemented in Elements, cat has been considered to be a covenant opcode only in conjunction with checksig from stack. In this post, which will be much mathier than later ones, we'll talk about how to abuse the math of short signatures to emulate functionality of check-seek from stack. So again, this side chain is coming out, right? Yeah. An open source side chain capable of, okay. So it looks like that this is used to demonstrate implementations. Not sure if it's only for demonstrations or also for production environments. Okay, so these are also really interesting articles. I will save them. And now I also will do some refresh. I will eliminate some of the things I saved today, because in the end they're not all really necessary. Like all the Bitcoin Optech newsletter, I will eliminate them as they don't really add much to the conversation, because I can go there on the Optech website and find them. Steven Rules, Covenants Wiki. Okay, so I will eliminate this, Covenants support, Covenants in Bitcoin, the taxonomy. Okay. Okay, nice. I'm satisfied with the work until now. So I have these sources I should go through, and from here I can build my next steps. Okay, so it's time to close this video. I'm satisfied. Of course, I'm starting this path, and it may feel like it's not really, how I would say, concrete. It's not really defined as a path, but I'm confident. There's a lot of material, good material, and now I have to study it so I can continue the exploration. Therefore, thank you for being here with me. I salute you and see you in the next video. Bye bye.